In this video we're going to look at chapter 18H on addition formula. Let's take a look at a unit circle, and we're going to choose any 2 points on the unit circle. We'll call them Q and P. And the angle that forms Q we'll call angle B, and the angle that forms the point P we'll call angle A. Therefore, the coordinates of Q are cosine B, sine B, and the coordinates of P are cosine A, sine A. We know a few other things about this picture. We know that the angle between these two lines is the angle A minus the angle B. We know that the distance from the origin to Q is 1, and that the distance from the origin to P is 1 because this is a unit circle. And now we can use the distance formula to find the distance between points P and Q. If you remember from geometry, the distance formula is simply the distance between any 2 points on the Cartesian coordinate system is simply the square root of x1 minus x2, or the x-coordinates, squared, plus y1 minus y2 squared, or the y-coordinates, squared. So in this case, the distance between points P and Q is cosine A minus cosine B squared, because those are the x-coordinates of the 2 points, plus sine A minus sine B squared, because those are the 2 y-coordinates of the points. Okay, get ready for some algebra here. We can square both sides of this equation to get P squared, and then we get rid of the square root sign on the right hand side. At the same time, we can expand each of these sets of parentheses. So we're going to get cosine squared A minus 2 cosine A cosine B plus cosine squared B. That's just the first set of parentheses, and the second set of parentheses is sine squared A minus 2 sine A sine B plus sine squared B. So that's quite the expansion for the right side of the equation. But we're gonna simplify a few terms here. Notice we can't do much with the cosine squareds and sine squareds yet. So let's write cosine squared A plus sine squared A plus cosine squared B plus sine squared B. And then notice that these two terms with the cosine A, cosine B, both have a factor of, or are multiplied by minus 2, so we can factor out that negative 2, and on the inside we'll have cosine A, cosine B, plus sine A, sine B. Okay, now you may have noticed the first 2 terms are cosine squared A plus sine squared A. We know from our previous studies that that is equal to 1. Likewise, cosine squared B plus sine squared B is equal to 1. So really both of these can be replaced by 1. That gives me 2 minus 2 cosine A cosine B plus sine A sine B. So this is the distance PQ squared. Let's take a look at this from another angle, pun sort of intended here. Through the cosine rule, which we learned in a previous section of this chapter, we have PQ squared equals 1 squared plus 1 squared minus 2 times 1 times 1 times the cosine of A minus B. And you can go back and look at the diagram up here, right? We have this side and the angle between, so we can use the cosine rule to find this side. And that's what we've done down here. So now I have two expressions for PQ squared. Notice that the second expression can be simplified to 2 minus 2 times the cosine of A minus B. Well, the first part of the expression looks very similar. By comparing this equation to this equation, I can prove that the cosine of A minus B equals cosine of A times the cosine of B plus the sine of A times the sine of B. And this is our first addition formula. Now I'm not necessarily going to ask you to prove the addition formula over and over again. I don't necessarily need you to know where that comes from. I wanted you to see it. More importantly, I want you to memorize the 4 addition formula that we have. And we can develop the other 3 from the addition formula that we just saw. And that's the cosine of A minus B equals the cosine of A times the cosine of B plus the sine of A times the sine of B. I won't bother going through the proofs of the other 4, but you can develop them from this formula right here. So here are the other 3. We have cosine of A plus B, which equals cosine A cosine B minus sine A sine B. We have sine of A plus B, which equals sine A cosine B plus cosine A sine B. And we have the sine of A minus B, which is equal to sine A cosine B minus cosine A sine B. So there's a couple tricks to remembering these. For cosine, you notice that the signs in the middle are switched, and that the first term is cosine cosine and the second term is sine sine. For the sine addition formulas, you see that the signs in the middle are the same, so here plus and plus, and I alternate sine A cosine B and cosine A sine B on either side. And those are our 4 addition formula. Let's take a look at a few examples. Okay, in the first example we want to expand the sine of alpha minus beta. And using our formula, we can just plug in alpha and beta for A and B. So we will get sine alpha cosine beta minus cosine alpha sine beta. And that's the third formula on the previous slide. In the next problem, we want to expand cosine theta minus alpha. And this is the original formula that we came up with. And again, we can just plug in theta and alpha in for A and B. So we have, sorry about that. Okay, so we have cosine theta, cosine alpha plus sine theta sine alpha. Okay, let's look at a slightly more complicated example. Okay, in this last example problem, we want to expand and simplify cosine alpha plus 90. So again, we're going to use one of the formula, and it's the second one that we listed of the four. So our first step is cosine alpha cosine 90 degrees minus sine alpha sine of 90 degrees. And now because we have a number, we can actually do some real simplification here. Remember that the cosine of 90 degrees is 0. So I have cosine alpha times 0. And the sine of 90 degrees is 1. So I have sine alpha times 1. Well, this first term cancels, and the second term is simply minus sine alpha. And that's our answer. Much more simple than our cosine alpha plus 90. And you can practice more of these in the textbook.